Welcome to Lesson 9.1, Rational Functions. This is a basic beginnings to the whole chapter. Okay, we're going to talk about, first of all, a rational function. And please excuse me, I do not have my airliner, so I'm using my mouse for this. So a rational function is an equation of the form. Now, rational, remember it comes from ratio, which means fraction. Okay, so if you look at the form of the function, it is a fraction, where p and q are polynomial functions. Now, because it's a fraction, we cannot have a 0 in the denominator, otherwise it's undefined, hence this little piece. Now, if you have a function in the denominator, and you will, you cannot have an x value that could cause that to be 0. And we'll see what that means in a moment, but if you have something like that, it's called an excluded value. An asymptote is a line that a graph approaches but never touches. And you've seen this with some of the parent function graphs we saw earlier in other units, and we'll see what they look like as well. So what are the excluded values? Again, an excluded value is a number that can go into the denominator and cause it to be a 0. So the really basic way of doing this is just taking the denominator and saying, how can I make it equal 0? Now, when it's just an x, that's pretty straightforward. It's 0. So the excluded value for example 1 is 0. Now example 2, here's your denominator, and again, you'll do the same thing. You would say, how can I make 4x minus 8 equal 0? Okay, so we would just say then 4x minus 8 equals 0, and then solve for x. So we would add 8 to both sides, and then we would divide by 4. So the excluded value for this equation, or this function, or rational function, would be 2. If we were to plug 2 in, this denominator would be 0, and then therefore it would be undefined, and that's unacceptable. Okay, now when you're looking at the functions that you will get in this chapter, in this unit, are going to look of this form. Now, when it's in this form, just like when we looked for vertexes and things like that, vertices on our quadratic functions, this form tells us a couple things. Our vertical asymptote, again a vertical line where our graph will approach but never touch, is whatever causes the denominator to be 0. Okay, that's this part. Whatever causes the denominator to be 0. In this case, if you look at this algebraic expression, it would be b. The horizontal asymptote, a left and right line, that a graph would approach but never touch, is equal to c. So in other words, the constant. Okay? The domain and range is something you want to think about. The domain of a rational function, again, domain, okay, that's the x values, is a set of all real numbers, all reals, except whatever causes that denominator to be 0. The range is a set of all real numbers, again, all real numbers, except whatever that c value is, or wherever that vertical asymptote is. And we will see what, or horizontal asymptote is, and we'll see that in some examples. Identify the vertical asymptotes and horizontal asymptotes of each. Then make a table of values and sketch the graph. It's important to know where the asymptotes are, because then you can decide what numbers you will need to plug into the equation. Because you want to go put some values in there on the left of the asymptote and on the right. So, because it looks different. So for example, in this one, we notice that whatever causes the denominator to be 0 here, I'll do the same method, x plus 2. That is equal to 0. Then we say, how will that be equal to 0? We would subtract 2 from both sides. So negative 2 will be a vertical asymptote. So I'm going to draw a line at negative 2. I'm going to make it dotted, because our graph's going to approach that but never touch it. There's no c on the right here. There's nothing. So that means our horizontal asymptote is at 0. All right, so now what do we graph? Well, again, we want to pick some x values that are on the left of our vertical asymptote. So let's try a negative 4. a -3. Now at -2, it's undefined. Okay, so we're not going to get anything there. Let me plug in a -1, plug in a 0, and a 2. When we plug in these numbers, we would have on a calculator, if I plug that in at -4, so we would have 2 over, and I'll just do this one by hand, and then I'll go with the rest automatically. So if I plug in a -4 plus 2, we'll get 2 over, again, I'm sorry, I'm writing this with my mouse, so it's a little sloppy, I apologize, over -2, and 2 over -2 is a -1. This is a 2. Okay, so we would write a -1 here. If I did the same with -3, we'd get a -2. At -2, we'd get a 0 or undefined, which we couldn't do. -1, we get a 2. At 0, we get a 1. And at 2, or excuse me, oops, I forgot about that. Pardon me. This should be a 1. So at 1, and then I'll put a 2 here. At 1, we get 2/3, so 0.67. And a 2, we get a 1/2, or 0.5. Now, if we graph these points, we have basically, or a little basic picture, we have -4, -1, so right here. We have -3, -2, right here. We have -2 is undefined, -1 is at 2, and 0 is at 1. 1 is at 2/3, 2 is at 1/2. So here's what it's going to look like. You're going to get this line going downward, but curving, and it's going to approach the dotted line, but not cross it. You're going to have it going upward, and that's going to go upward and approach the vertical asymptote, but not cross it. Nothing is going to be here. Nothing is going to be here. And this one's going to be similar to that. It's going to curve like this, and it will approach those lines but never cross. So this is a graph that's only in the first, or sort of in the first and third quadrants, but it's shifted, so it's not quite there. And not quite in just the first and third quadrants. But nothing is in those places, okay? And that's basically all we need, as long as we understand that they're going to approach but not cross those dotted lines. Next one, again, asymptotes. Well, we have the denominator, x minus 2, so the vertical asymptote is going to be at 2. The horizontal asymptote will be the constant, which is right here. That's a 1. So we graph that. So at 2 is where it's undefined, so that's a vertical asymptote. At the 1, that's the horizontal asymptote, so that's on the y-axis. Those are our two vertical asymptotes. So let's plug in some numbers that are opposite or on either side of the vertical asymptote. So that would be 0, 1, and at 2 it's undefined, and then 3, 4, 5, and 6, and you can pick more than this. So if we plug in those numbers, if I plug in 0, notice there's a negative out here, so don't forget that. If I plug in 0, I'm going to get -1 over a -2 plus 1. Again, I'll do the first one by hand, which is 1/2 plus 1, which is 1.5. So I'll do 1.5. If I plug in a 1, I get 2. If I plug in a 2, it's undefined. If I plug in a 3, I'll get a 0. If I plug in a 4, I'll get a 0.5. If I plug in a 5, I get 2/3 or 0.67. Sorry about that, I am in school doing this. So I get 0.67, and then number 6 is a 3/4 or 0.75. If I graph these, we have 0 is at 1.5 right there. 1 is at 2, and 3 is undefined. or excuse me, 2 is undefined, 3 is 0, 4 is at 0.5, 5 is at 2/3, and 3/4, and so on. So again, it's going to approach the dotted line but not cross it. It's going to go this way towards that dotted line again and bend downward if I were to put some smaller points in there. This one, it's going to go up towards it but never cross it. I made a mistake here with this one. See how the bottom of this red line curves upward? That shouldn't happen. I just can't do it very easily here. It should be curving downward and getting closer and closer to that dotted line, but never crossing it, but it doesn't curve back up. So again, notice the graph is only in 2 of the 3 quadrants left when you made these asymptotes. All right, so that's it. Here's our form of the equation. From it, we can get horizontal and vertical asymptotes. We pick some x values on either side of the vertical asymptote, plot those points, and get kind of an estimation of how it's going to be graphed. You can definitely plug in more points if you like. You can use your graphing calculator. That works too. Just be careful how you plug it in to make sure you're entering it right. And that means in parentheses on the denominator. That's what you'll need to do to get it graphed right on your calculator. And then, knowing the general form of these rational functions, you can kind of sketch in the rest. And this ends lesson 9.1.